Alright, welcome to today's lesson on multi-stage probability, which corresponds with set 9C in the textbook, I'm pretty sure. Alright, so multi-stage is really just events or trials that have multiple parts, or two, three, and so on. And I'll explain what I mean. So the classic example is when a coin is tossed 3 times. Alright, so you can have toss 1, toss 2, toss 3. We could have 2 results here, head or tail, 2 results here, head or tail, 2 results here, head or tail. And what we're going to specifically look at today is how to arrange them so that we can see the sample space very clearly. All right, so the most straightforward way, which you should remember, is with a tree diagram. All right, so you might go, here's round 1, we could have 2 results, head or tail. Then from the head, we could have 2 possible results for round 2, head or tail. From the tail, we could have also 2 possible results for round 2. So if I tossed a head in round 1, I could go to round 2 and toss a tail. Or if I tossed a head in round 1, I could go to round 2 and toss a head. All right, now from round 2, each result could have 2 other possible results. This is where it starts to get complex. So we can see here that there are 1, 2, 3, 4, 5, 6, 7, 8 possible results. All right, so there's 8 total, and each one, to find out what each one, the sample space, we just go along the path through the rounds. So this one is head, head, head. The next one is head, head, tail. The next one is head, tail, head, head, tail, tail. And then we drop into the ones that start with tail, head, head, then tail, head, tail, 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 head, and tail, tail, tail. Now this is the sample space. Okay, there are 8 possible results, and you can see what the results are, and you can also see that order does not matter. Sorry, order does matter. So 2 heads and a tail is different from this one here, which goes tail then 2 heads. All right, but depending on how we phrase what we're looking for, we could count both of those together because they both have 2 heads. Okay, so let's have a look at a few questions. We might start with find the probability that 1 head is observed. All right, so PR head, just 1 head. So let's look through the results and find all the ones that have 1 head. So there's 1 there, there's 1 there, there's 1 there. I think that's it. So it's 3 out of 8. Okay, find the chance that at least 1 head is observed. So this is slightly different. It has to be greater than or equal to 1 head. Okay, so now we've got those 3, plus this one has 2, this one has 2, this one has 2, and this one has 1. So that is 7 out of 8 results. Find the chance that the second toss results in a head. So now we're looking at only the second one, which is this middle column in here. So we can have a look at which ones of those underlined in green have a head in there. So there is 1, 2, 3, 4 out of 8. So you can choose how to write it here. Second head like this. And it was 1/2, which was 4 out of 8. And then find the chance that all heads or all tails are observed. And you can see here 3 heads or 3 tails. And we'll just call it 3HT is 2 in 8, which is the same as 1 in 4. All right, so if we can, we should simplify these ones. And remember the one above was actually 4 in 8, which was the same as 1/2. All right, so when doing multi-stage probability, it's important to remember that we need to see the entire sample space before we start answering questions. So when we have more than 2 stages, we need to use a tree diagram, which can get messy after 3 stages because there's so many lines going everywhere. if we don't have 3 stages, if we have 2 stages, we can use a two-way table, and I'll show you what one of those looks like in this next problem here. And this is another classic example that we see quite frequently in probability and methods. So we've got find the probability that when 2 fair dice are rolled, the same number shows on both dice, and the sum of 2 numbers shown is greater than 10. So a two-way table looks like a table, and it's going to have 6 divisions both ways, and that's nicely done there. I might enlarge it to make it easier to read. There. All right, so down each side, we just write the numbers that are possible to roll. All right, and it's called a two-way table because we can see that it's going to work down and across, so 2 ways. And then in each box at the crossover, we write the possible result. So on the first dice, we'll call this one the first dice here, and the second dice here, we could have a possible 1 on the first dice and 1 on the second dice. We could have 1 on the first, 2 on the second, 1 on the first, 3 on the second, 1 on the first, 4, and so on. Now, let's go back and have a look at the question. Yep, we're doing it right because it asks for the same number on 2 dice. So we've got to go through and fill out the entire sample space, which is this stuff in blue that I'm doing. Because remember, to answer probability questions, we need to know the sample space. And this is going to take a while, so I'll show you what it looks like completed right here. There we go. All right. So let's go through some of the questions. It says, find the chance that the same number shows on both dice. So we go through our sample space and we go, okay, so there's 1 there, 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 and there's 1 there. So it's clearly 6 out of something. And there's 6 results down, 6 results across, so it's 6 out of 36, which can simplify down to 1 in 6. All right, so there's a 1 in 6 chance that we roll a double. Find the chance that the sum of the 2 numbers shown is greater than 10. Now we notice that our sample space doesn't have the numbers added up, so we'll have to look at our heads and find out where it starts to happen. All right, so 3 plus 4 is 7, 3 plus 6 is 9, 4 plus 5 is 9, 5 plus 4 is 9, so we're going to see this one here is 10, 10, 10. So these 3 numbers here are going to have sums greater than 10, and those are the numbers we're interested in. So it's 3 out of 36, which will simplify down to 1 in 12. All right, so there's a 1 in 12 chance that we'll roll a number greater than 10, which is not a big chance. All right, so a couple of things to remember from this multi-stage probability. When we have multiple stages, there are 2 tools we can use. We can use a tree diagram, and tree diagrams are used when there's more than 2 or 2 or more stages. The other tool we can use is a two-way table. Otherwise, they can be called Carnot maps. But that's just a funny, fancy way of saying two-way table. And these only work when there's 2 stages. All right. So they can be quite helpful. Later on, I think in the next set, we're going to look at a more complex way of using these two-way tables. Okay, so the 2 tools we're using today are tree diagrams or two-way tables.